All right, hello. We are going to be working through this trusty triangles problem. So let's see what this header gives us. It says fill in the polygon and triangle classes below according to the problem descriptions in the doc test. Polygons are represented as a list of points, and triangles are polygons represented by a list of exactly 3 points. Okay, so it looks like we have these two classes here. Let's walk through it. We have this polygon class. And the first thing we notice is we have a shape counts class variable, which seems to be a dictionary. We'll get to what that is later. Then we have our constructor. We have a count by sides method and a find area method. Then we have this triangle class here, which is going to inherit from the polygon class. And it has its own num triangles created method, and it's going to overwrite the find area method of the polygon class. Okay, so let's jump into the first problem, part A. So it says, first up, to complete the init method, or our constructor. And it wants us to do it so that the class attribute shapeCount stores key value pairs where the key is the number of points and the value is the number of polygons created with that number of points. So what they mean by that is basically, let's say we make a square here that has 4 points. When we do that, we want to add a key in our dictionary. So where the key 4 in our dictionary, and we want to set the value to that equal to 1, basically meaning there is one polygon created that has 4 sides to it. And then that way, when we make this other square, we're going to update that key in our dictionary so that the value is 2, right? And we see that here. When we run the count by size method on num sides 4, we get the output 2. Cool. And then also in this case, we make a triangle. So if we want to keep this model up, we would make another entry with 3 sides, and that has the value of 1 corresponding to it. And then it also says here that every polygon instance should have its single instance attribute points, which is bound to the list of points representing the polygon. Okay, and that seems to be just passed into the constructor, so we shouldn't worry too much about that. We'll get to that. And then finally, we're also going to complete the count by sides method, which is going to use this class attribute shapeCounts to return the number of polygons that have been created with num sides. Okay, cool. So let's start with the init class. And step 1 is going to be to, let's say step 1 is assign points instance attribute. And we'll say step 2 will be to update shape counts. Okay, let's start with step 1 here, and that's going to be to assign our points instance attribute. So we are already passed in a list of points from the constructor, right? We see that here. So all we want to do is now tie that as an instance attribute to self. So we could just say self.points equals points, right? The points that we passed in. Cool, cool. So that's our step 1 done. But now we also want to update our shape counts dictionary, right? That class variable in Polygon. So that will be dedicated to all of these lines. That'll be our step 2. So the first question you might be asking is, why do we have an if else here? And try to think of the condition. Why would we want to treat it? Why would we want to, because we're just updating a dictionary. Why does it matter? Why do we need a condition here? The key realization to make is we want to have different behaviors depending on whether or not the amount of the number of sides of this polygon we're creating already has an entry in shape counts, versus if we are going to have to create an entry for the first time. So let's walk through it. If the length of self points, length of self.points, and remember, this is equivalent to like the number of sides, right? Because every entry in the points dictionary is a point, or in the points list is a point. So the length of that list is the number of sides, right? So if that length, let me fix this S, is already in self.shapeCounts, right? And we're saying self here because it's a class variable for polygons. Then if it's already in there, then we know that entry already exists, right? So all we have to do is now update that entry by adding 1 to it. So how do we do that? Well, if we want to actually edit the shape counts, we want to make sure that we are calling it from the polygon class directly because we want to update it for the entire polygon class. So we will write polygon dot shape counts. And then we want to index into the entry that has this link self points, right? And at this point, if we've hit this line of code, we know that this is an entry that exists in our dictionary, right? So this is some number. This is some integer. So all we want to do at this point is just to say plus equals 1, right? Because we're adding 1 to that. Whatever entry was already in there, we want to increase that by 1 because now we're creating a new polygon that has that number of sides. So what's our else case? That means this a polygon with this number of sides has not been seen before. It's not been created before. It's not accounted for in our shape counts dictionary. So what we'll have to do is actually have to create that entry, which looks very similar to what we just did on the above line. We'll do polygon shape counts length of self.points. But this time we can't plus equals it, right? Because there's currently nothing there. So what we're going to do is we will just set that equal to 1. And this is going to create that entry in the dictionary. And the reason we're setting it equal to 1 is because now we just created a new polygon that has that number of sides. So we know there's at least one. We know that there's exactly one polygon with that number, with that number of sides. And then that way in the future, when we call one that has the same number of sides, it can actually hit this if statement and bump it up by 1. Cool. So that is our constructor done. We are done with the init method. But we can't forget about this count by sides. This wants us to return the number of polygons that have been created using our shape count dictionary. So return number of polygons that have num sides. Okay, well, we have an if and else here again, right? So what's the if and the else? Well, let's think. If we have our shape counts dictionary that we are now updating every time we make a new polygon, right? So we could say if this number of sides exists in that dictionary, right? If it's in this example, if it's 4 or 3, for example, all we would have to do is get the value that's assigned to that key, which is pretty straightforward, right? We can just say if num sides is in, and we're gonna say polygon.shapeCounts here, right? I was able to do self.shapeCounts here because we passed in self, but here we have to reference it by the class polygon.shapeCounts. In which case it would just be polygon.shapeCounts, and we're just going to index into the key num sides. So that's going to give us the value associated with that key, which, because we're updating it every time in init, will be the correct number. But one thing to consider is that shape counts is only ever holding the num sides that have been created before. So what happens if num sides isn't held in shape counts? Well, that just means that we have yet to create a polygon that has that number of sides. So that means the answer is just 0, right? And we see that here when we did count by sides 10. Because we haven't made a polygon with 10 sizes or whatever, that key is not going to be in our shape counts. So if that is the case, then we just return 0. That polygon has not been made before. Okay, cool. That is part A. Now we have complete number of triangles created, so that it returns the number of triangles that have ever been created. Remember, triangles are inherit from polygons, and they always have 3 sides, right? And we're given this doc test here. Starts with a clean slate, and it says they make 1 square, they make 1 triangle, and when they call num triangles created, they get 1. And when they make another one, they get 2, right? And notice it says here, you may not need to use all the lines for a correct solution. Well, if you think about it, the function we just wrote does a very similar task to this, right? Where it gets you all the polygons that have a certain number of sides. But we know triangles will always have 3 sides. So what we could do, and remember we're in the triangle class at this point, this num_try is created. If we go back to our diagram, this is in triangle. So what we could do is we could call on this count by sides method in the polygon class. And we can simply return polygon count by sides of side length 3. Because all triangles have 3 sides, and all 3-sided polygons are triangles. So this will actually work. Sorry, let me clean that up. Count by sides 3. So we can use the method we literally just wrote to get us the number of triangles based on the side length, and this will work perfectly fine. Cool, so that's part B. And now we have part C, and this is really tricky. So let's read through this very slowly. So we're going to complete the find area function, so it returns the area of the polygon. Now, if we go back up here, notice find area was part C for a class polygon, but we do also have a find area that's correctly implemented in triangle. It's given to us correctly implemented. Now, this sentence is very important. Crucially, you may assume that the list of points in the polygon are ordered in the counterclockwise direction, right? And that makes this diagram very, very helpful, and we'll get to that in a second. And it tells us here the circled integers in the box indicate the index corresponding to the point. So this is index 0, 1, 2, 3, and 4, right? These points here correspond with those indices. Also, since all polygons can be broken into triangles, you may find the correctly implemented find triangle function in the triangle class useful. Okay, so they're giving us some hints here. They're telling us instead of making a find area method that works with any polygon, we should use the already correct find area for triangles and apply that to any polygon. Okay, so let's get a good understanding of what's exactly happening in this photo. So let's move in the counterclockwise direction. So we start here. So it tells us that the first triangle is created based on these 3 points, right? These 3 points make up our first triangle. And so what we can do is we can start summing up the areas of these triangles, right? So first we have this triangle. Then the next triangle seems to be these 3 points, right? And then the last triangle seems to be these 3. And what we could do is sum up triangle 1, 2, and 3, and that'll get us the area of the entire polygon. So let's go through that slow again. The first one is these 3 points. The second one is these 3 points. And the last one is these 3 points. You can start to see a pattern a bit where this first 0 element is part of every single triangle, right? It's part of this one, it's part of this one, and whatnot. And the only thing that's changing is that we are removing the second point in the triangle and instead replacing it with like that next point, right? So in this case, it was 1, 0, 2. Then we got rid of the 1 and did 0, 2, 3. Then we got rid of the 2 and we did 0, 3, 4, right? So that's kind of the the path that we're going to take for this problem. And it is natural to do this problem with recursion, because we are kind of breaking down this polygon into smaller subparts of triangles. So let's see how we can apply this based on the skeleton code. First thing they have here is the base case. If the length of self points, aka the number of sides left, is less than or equal to something, then return something. Well, let's think about this. My guess would be any length with 2 sides, right, is just a line, and that's not going to have an area associated with it, right? So I think a good base case would be if it's less than or equal to 2, then the area is going to be 0, right? Or I guess I should be writing this down here. Sorry. Length is less than or equal to 2, then we're going to be returning 0, right? Because that's just going to be a line. There's not going to be any area associated with it, right? So there's no more reason we need to break down this problem anymore. Okay. Otherwise, it has first triangle here is the line we're given. First triangle. Well, think about it. We want to use the find area method from the triangle class. But the only way we can do that is if we actually create a new triangle object. So I think for this first triangle here, we should actually be creating a new triangle. So let's do that. let's call on our triangle class. But now the question becomes, what are the points we're going to pass in? Because if you remember, a triangle's constructor is the same as the polygon structure, and that just takes in a list of points, right? So what are those points that we're going to pass into it? Well, let's look at our drawing. What's the first triangle we did? 0, 1, 3. Or 0, 1, 2, right? Those first 3 elements of the list was our first triangle. So let's do that. Let's do self.points. And now how do we get the first 3 elements of the list? Well, we can use list slicing, right? We can do 0 to 3. Right? And that way we get those first, we'll get indices 0, 1, and 2. So that's perfect. So now we have successfully made this first triangle, right? Great. Now it tells us points copy. Points copy. Why do we need a copy of points? What's the point? Well, the basic idea is what we're going to do at this point is we are going to not only create this triangle and get its area, but we also want to set up our list of points so that in the future, when we do our next call with the remaining triangles, we want to make sure that their lists are properly set up so that when they grab the first 3 indices, it is the correct first 3 indices, right? But we don't want to change, we don't want to modify the self.points that's passed in from the self object here, because then that's going to mess with the polygon that we called find area on. That's going to actually be changing its points. And we don't want to do that. So the whole point of points copy is to make a copy of the self.points list so that we are free to modify that copy and pass it into our recursive call. Hope that makes sense, because otherwise then we'd actually be changing the points of the polygon we passed in, which we don't want to do. We just want to find the area. And a good way you can make a copy of a list is to use slicing and just have a colon in there. So we're not actually slicing any elements off. We're simply just making a new list that has the same elements in the same order. Okay, and now we have made a copy of our list, and now we have pointsCopy.pop. Okay, pop is going to remove an element, and for lists we put the number index in there. So we're going to be removing a list, or we're going to be removing an element from a list. Okay, let's think. Which one should we remove? Well, remember, when we walk through it, we'll walk through it one more time. We did 0, 1, 2. Then we did 0, 2, 3. So what happened there in 0, 1, 2, we popped off the 1. In 0, 2, 3. And then we're going to pop off that 2 and then do 0, 3, 4. So it seems like the first index of the list is always going to be there. And the only thing changing through iterations is that second element, aka index 1, is getting popped off. So it seems like the strategy would be to actually pop the element at index 1 to set us up for the future, set us up for our recursive call, right? Well, now we are at our recursive call, and there's a plus here. Interesting. Why is there a plus here? Well, think about it. We want to add the area of the triangle we just made, right, this first triangle, to the area of whatever we call when we call find area on our updated popped list. So we're going to say return first triangle dot find area. And remember, this is correctly implemented for us because they have a correctly implemented find area function in the triangle class. So this is actually going to get us a value. But then what we're going to do is we're going to now create a new polygon based on our points copy. And the reason for that is so that we can call, find area on that. And what that's going to do is it's going to work its way down, make this triangle, add this triangle to this one until it gets to a points list that's less than or equal to 2 and return 0 and gets us a value. So we're going to say plus polygon of, and what are we going to pass in? Well, we're going to pass in our points copy that we remove the first element from, right? Points copy. Now this is creating a new polygon And in the example here of this first call, it's creating a new polygon that has points 0, 2, 3, and 4, right? It's basically creating this shape. And the reason for that is because we already know the area of this shape. We used a triangle there. And we are going to add the area of this shape to the area of this shape, right? And what that call is going to do is then make this the first triangle and then call on find area of this triangle, right? So eventually we've broken it down into subparts where it's all triangles, and we're splitting it into these three and we're summing them all together. So that's the basic idea. So we are going to, the idea is we're creating the polygon for the rest of the shape that is not included in this first triangle we made. And then we're going to call find area on that new polygon. Sorry, I'm very much going off the page here. I'll try to write that smaller. Find area. And we are done. Don't get too discouraged if you were stuck on this problem. This is quite a difficult problem, but I hope that helped. Thank you.